Alright, let's try to evaluate the double integral by first changing the order of integration. Alright, so here's the double integral from 0 to 2 and from y squared to 4 e to the x over square root of x dx dy. Alright, so let's start with that. Alright, I'm going to sketch the region we're integrating over. Alright, so I'm going to put the xy axis. Right? So the lower limit of the inside integral is x equals y squared, which is a sideways parabola looking like this. And the upper limit is x equals 4, so it's the vertical line there. All right, then the lower limit of the outside integral is y equals 0, so it's going to start from here. And then it's going to go up to y equals 2, right? So this is the region. Right, since we don't know how to find an antiderivative e to the x over square root of x with respect to x, I'm going to switch the order of integration. So I'm going to integrate with respect to y first. Alright, so since we're integrating with respect to y first, I'm going to hold x constant. Then looks like it's going to start from y equals 0. So I'm going to put 0 for the lower limit. And then it's going to go right up to this top curve, which is y equals square root of x. So I'm going to put square root of x for the upper limit. Right? Then we'll try to swipe the whole region. So we're going to start from x equals 0. So I'm going to put the x equals 0 for the lower limit. Then go up to x equals 4. So I'm going to put 4 for the upper limit, right? So we have a new integral with the order of integration switched. Let's try to evaluate this, right? So let's take care of the inside integral. Right, so e to the x over square root of x has nothing to do with y, so it's considered to be a constant. So antiderivative is e to the x over square root of x times y. And y goes from 0 to square root of x. Then we plug in square root of x, we get e to the x over square root of x times square root of x. Minus, if you plug in 0, it's 0, so I'm not going to even write that. Right, so we can cancel square root of x's. And then if you find an antiderivative of e to the x, we get e to the x. X goes from 0 to 4. Plug in 4, you get e to the 4th power, minus plug in 0, e to the 0 is 1. So we have e to the 4th power minus 1. Right, so therefore, the value of this double integral is e to the 4 minus 1. Right? That's it. I hope that this was clear.